What specific problem does the proposed method aim to solve regarding reasoning models, and how does it improve upon existing models in handling ill-posed queries?
The proposed method aims to address the issue of overthinking under missing premise, MIP overthinking, in reasoning models, which leads to excessively long and redundant reasoning paths for ill-posed queries that lack necessary premises. Existing reasoning models often generate significantly longer responses, 2 to 4 times more tokens, without effectively identifying the missing premise, resulting in inefficient and verbose outputs. In contrast, the proposed method systematically constructs a suite of MIP questions to evaluate and highlight these shortcomings, revealing that non-reasoning models can more quickly recognize and abstain from ill-posed questions. By employing 3 distinct strategies for generating MIP questions and analyzing model responses across various datasets, the method demonstrates that reasoning models struggle with critical thinking, often revisiting the same reasoning steps without reaching a conclusion. Ultimately, this approach provides insights into the limitations of current reasoning models and emphasizes the need for improved critical thinking capabilities to handle ill-posed queries effectively.
How does the proposed method work? Illustrate it step by step, specifically detailing the processes in generating and evaluating MIP questions.
The proposed method for investigating overthinking under missing premise, MIP overthinking, involves a systematic approach to generating and evaluating MIP questions. First, the researchers construct a suite of MIP questions using 3 distinct strategies: rule-based generation, where formulas with unassigned variables are created; body question swapping, which mismatches problem bodies with their corresponding questions to introduce logical inconsistencies; and essential premise removal, where critical premises are deliberately removed from well-formed questions to render them unsolvable. Next, these MIP questions are sourced from 3 math datasets, SVAMP, GSM-8K, and Math 500, across varying difficulty levels, ensuring a comprehensive evaluation of reasoning models. The evaluation process involves empirically testing a range of state-of-the-art large language models, LLMs, on these MIP questions, focusing on 3 key metrics: the length of generated responses, the accuracy on well-defined questions, and the abstain rate on MIP questions. This structured methodology allows for a detailed analysis of how different models handle well-defined versus MIP questions, ultimately revealing significant insights into the limitations of existing reasoning models and their lack of critical thinking capabilities.
Can you provide a simple yet illustrative example of how the MIP overthinking phenomenon manifests in a reasoning model when faced with an ill-posed question?
An illustrative example of the MIP overthinking phenomenon can be seen with the question, "What is the value of a?" This question is ill-posed because it lacks any premise or context regarding the variable a, making it unsolvable. In response, a reasoning model like DeepSeek R1 may generate thousands of tokens over several minutes, engaging in extensive and redundant reasoning without arriving at a meaningful answer. This behavior highlights the model's failure to recognize the missing premise, as it continues to produce lengthy outputs instead of promptly indicating that it cannot proceed. The excessive token generation in this scenario exemplifies the MIP overthinking issue, where the model's reasoning process becomes inefficient and unproductive due to the ill-defined nature of the query.
What are the theoretical and practical benefits of the proposed method in comparison to state-of-the-art LLMs, particularly in terms of efficiency and critical thinking capabilities?
The proposed method addresses the inefficiencies and lack of critical thinking capabilities observed in state-of-the-art LLMs, particularly in the context of overthinking under missing premise, MIP overthinking. Theoretically, it emphasizes the importance of identifying missing premises in ill-posed questions, which allows models to terminate reasoning processes early rather than engaging in redundant and lengthy outputs. Practically, this leads to a significant reduction in response length, up to 2 to 4 times shorter compared to existing reasoning models, while maintaining or improving the abstain rate on MIP questions. Furthermore, non-reasoning models demonstrate a greater ability to recognize and respond appropriately to ill-posed queries, showcasing a more robust critical thinking capability. Overall, the proposed method enhances both efficiency and critical thinking by promoting a more discerning approach to reasoning, ultimately leading to better performance in ambiguous conditions.
How was the proposed method validated or tested? Describe the experimental design, datasets, and evaluation metrics used to assess the effectiveness of handling MIP questions.
The proposed method was validated through empirical evaluation of a wide range of state-of-the-art large language models, LLMs, using a suite of missing premise, MIP questions constructed from 3 math datasets, SVAMP, GSM-8K, and Math 500, and a synthetic dataset of unsolvable formulas. The experimental design involved generating MIP questions through 3 strategies: rule-based generation, body question swapping, and essential premise removal, ensuring a controlled assessment of model responses. The effectiveness of handling MIP questions was assessed using 3 evaluation metrics: response length, measuring the average number of tokens generated; abstain rate, the proportion of responses where models correctly identify the missing premise; and accuracy on well-defined questions. The analysis revealed significant differences in how reasoning models and non-reasoning models handled MIP questions, with reasoning models producing excessively long responses and low abstain rates, while non-reasoning models generated shorter responses and demonstrated better recognition of MIP. This comprehensive evaluation highlighted the critical shortcomings of existing reasoning models in effectively addressing ill-posed queries.
What specific results were achieved with the new method, particularly regarding response lengths and abstain rates, compared to both reasoning and non-reasoning models?
The study revealed that reasoning models exhibited a significant increase in response lengths when faced with missing premise, MIP questions, generating 2 to 4 times more tokens than when addressing well-defined questions. For instance, models like DeepSeek R1 produced over 3,000 tokens in response to MIP questions, compared to approximately 1,000 tokens for well-defined queries. In contrast, non-reasoning models maintained similar token counts for both well-defined and MIP questions, indicating their robustness to ill-posed queries. Additionally, the abstain rates for reasoning models on MIP questions were notably low, with many failing to recognize the unsolvability of the questions despite their lengthy reasoning paths. This starkly contrasts with non-reasoning models, which generated shorter responses and demonstrated higher abstain rates, effectively acknowledging the presence of missing premises.